There we go. And welcome back to another stream. I've done some changes to my setup with I'm trying to use Social Stream Ninja chat to aggregate the messages in a different way and maybe perhaps if it works then display the chat messages on the stream. So we'll see if that works or not. I have a backup chat window open as well. So even if that doesn't work, then I will be able to read any messages. So it's not an issue for me at least. But anyways, it's been a few days, 4 days or something like that, 5 perhaps, since the last time I did a dev stream. And we did exercise 8. We finished it, I think. Building the bytes pair encoder. I asked it about that name somewhere down below. Byte pair encoding, so a byte pair encoder is my guess. Tiny byte pair encoder. We finished it, we tested it, and it worked as expected, which was really neat. Felt really good to get that working with the encoding and decoding of the text we supplied and stuff like that. And here we even have the last model with its vocabulary and the different merges and stuff like that. And yeah. Oh yeah, also the testing, we didn't do that one. And I'm honestly going to skip it, I think. I mean, I've already tested it here, so like doing this backup testing process feels, how should I say, it feels too extra. Like it's too much work for something that I will move on from. I mean, getting the testing the PyTest routine down is probably a good idea, but I just don't feel like it. Not right now. So then the next one is the exercise 9. And it says add a train bytes mode that starts from bytes 0 to 255 to guarantee full Unicode coverage, which is probably essential for a large language model. And frequency-based vocab ordering, IDs by token frequency. I don't know why you would want that, but there's certainly a good reason for it. Export merges / vocab to a simple vocab.json plus merges.txt format like GPT-2. Like ChatGPT-2 or what? I'm a bit curious about why it's specifying it here like GPT-2. Maybe this was a breakthrough they had when they made GPT-2 or something like that, perhaps. Anyways, I was considering starting a new chat, like having Rufus here summarize the progress again and starting over with the fresh context, but I think this chat window should support one more exercise. I mean, it's been like 3 exercises, I think. 6, yeah, 6, 7 and 8. One more should be no, it's better to not risk it. I changed my mind. I mean, it's quite a lot, and I have no idea if like I've heard like stories of GPT like clearing, like deleting message, or should I say conversations that run on too long. So yeah, It's better to not risk it. Well, in the worst case, I might just, or in the next to worst case scenario, I could be like locked out from typing anything more, and then I couldn't get it to summarize the progress. So let's just do that now. Summarize everything we've done so far and add it to the summarization I provided at the start of this conversation. Make sure you save anything of relevance to future exercises and the teaching plan in general. I'll be copying this into a new chat window. This should be good enough, I think. Summarize everything we've done so far and add it to the summarization I provided at the start of this conversation. Make sure you save anything of relevance to future exercises and the teaching plan in general. I'll be copying this into a new chat window. Let's just try this and hopefully we'll get a decent answer. I also hope it doesn't get confused about the context of this here. I provided at the start of this conversation. It should accurately access the first message, but who knows? Okay, so we don't actually get the text that I provided, but that's fair enough. I mean, that there's a smaller chance of an error, or should I say a printing error or something like that, if ChatGPT doesn't have to rewrite itself over and over again. It will make mistakes. So it's better for me to just straight up copy and paste it. So, the exercise 6 was the calculator. I'd already forgotten about that one. And yeah, then we had the text stats. And I'm a bit worried about this format. I mean, I can't copy these bullet points. Let me just check the formatting used here. there was absolutely no formatting. It might not be as useful for the AI, so let's copy. Wait, no, let's go back and check the end of this one here. So we got the same kind of formatting, okay. Then then that should be fine. Since it worked this time, it should work again. And I can't copy it like that. I need to manually. And then append this one here. Oh. And oh shit. Okay, then we'll have to do it like this. And then down, should we include let's try without this one here. It should get the memo anyways. So let's try new chat and paste in all of this. Oh no, we can't use it like this. We need to do it with thinking. The auto model is too cheap. It defaults to like the mini version of itself too often, and provides frankly incorrect answers like almost all the time, unless like the questions are super simple. It is like ChatGPT 5 without the thinking mode. It's like using Google search maybe, and then only getting like the and I mean like without the AI summary as well, because Gemini is pretty good, all the things considered. But I mean like using Google search and then only reading like the summary of the web page summaries, like, and combining them. That's what it feels like to only do ChatGPT without the thinking model. And then you get like all those strange websites, and you like have to take their information for granted. It's just awful, honestly. Proposing exercise 9 tasks. That seems wrong somehow. I mean, I already provided an exercise 9 here. It should be able to pick up on that one without me strictly like specifying down here. It's thinking for a very long time. Maybe it's finished now. Preparing for exercise 9. So hopefully we get actually like this exercise here and not a different one. A different one might not be bad in itself, but if we stray too much from this order here, then we might be going in a direction that takes us like in a circle. And we want a straight line towards the finish line. A straight path towards the finish line. Thought for 5 minutes. I mean, it felt like 5 minutes, definitely. Definitely. Okay, this is perfect as our handover. Next up, exercise 9, byte level BPE. Okay, here's a focus plan plus starter you can paste straight into your sandbox. What you'll build: train merges over bytes, not characters. We'll still split on white space and prefix each word with a space token so merges don't cross word boundaries. Encode by replacing merges in order, left to right, non-overlapping. Decode by expanding token IDs back to bytes. And UTF-8 decoding. Drop the very first leading space. Export as a bonus, GPT2 style, vocab, .json plus merges text. Frequency ordered indices for export only. Okay, so here we have the... Oh, it's still writing it out, okay. It's taking a long time. I should have done this before stream, but I didn't think it would take this long. I should probably not start writing before it's all done, because I've seen it like change stuff afterwards sometimes. My guess is that it does like a fast pass over like the information, and then if it finds anything like egregiously horrible, then it updates it. But it might also just be like a visual glitch. Okay, so we have a usage here, and then a test file. You can start by creating the file byte bpe.py. And I can close these down. I have no need for them right now. And why this design? Byte coverage. Starting from bytes 0 to 255 means every Unicode string is representable after UTF-8 encoding. No unknowns or unc. Space token per word. Merges stay within words, export stays readable. Merges stay within words. Okay. G stands in for space. Replay merges, deterministic encoding. Decoding is just expanding token bytes and UTF-8 decode. Frequency ordered export mirrors common tokenizer files without complicating the internal model. When you're ready, drop these files into your sandbox. No, I'm not just going to drop them in, I'm going to actually program this. Because dropping them in makes... I find it strange, or I suppose it's not that strange when thinking about it like a few seconds longer, that people want to simply have code to be able to like drop into, like they want the code already done to just simply drop them in. Having the AI provide the code and then writing it yourself afterwards is pretty inefficient if you want stuff done. But it's the only way to learn, I think. From collections import counter. Collections. And from, to move my keyboard a bit, from typing, import iterable, list and tuple. Base ID 256, base vocab bytes 0 to 255 plus space token add 256. So is this simply a an empty value or something like that. It's like a character that doesn't exist or something. We have a function called normalize and text parameter called string, a asterisk, do norm, which is a boolean, and to lower, which is a boolean. And we want to return a string. Keep it simple for byte level. Case fold only if requested. Where did I go? Oh. Is it due to not returning anything? Okay, so return. Yeah, that solves it. Good, great. So if to lower, then we set the text to itself with case fold. We avoid NFKC here to keep bytes stable. Unless you want it. If do norm text Unicode data.normalize and NFKC text return text. Gonna check this for errors. Unicode. So I'm actually missing a import perhaps. Is it sort Unicode data? I'm gonna leave it out for now and simply have it like this, but it's good to know. So we only do the case folding here, or the lowering of any potential characters. And we don't normalize. Is it simply due to not require it when using bytes? Let me ask. When doing a byte BPE, is there a reason to not do NFKC normalization on the text data and only do like the case fold?
Sure, let's break that down a bit. So when you're doing a byte level BPE, the whole idea is that you're working directly with raw bytes rather than Unicode code points or normalized text. That means you're kind of dealing with the data in its most raw form, which can be useful if you want to preserve all those subtleties and not lose any information. Now, NFKC normalization actually changes some characters into their compatibility forms, which can alter how certain text is represented. If you're just doing case folding, you're just lowercasing things and keeping the character structure pretty much the same. So the reason you might not do NFKC is that you don't want to normalize away those details. You want to keep all the byte level distinctions as they are. So in short, it's about preserving the original byte level details and only doing minimal transformations like lowercasing rather than more complex normalizations.
Interesting. Very interesting. And kind of what I suspected, if I'm gonna be honest. Then we have another function called words. It has a parameter called text, which is a string. I want to return a list of strings. And split on white space only. Punctuation stays inside words. Return text dot split. Def text to byte sequences. Want a text string, and we want to return a list of lists of integers. And I'm gonna copy this. Each text to a list of word sequences of token IDs. Convert text to a list of word sequences of token IDs. Each word sequence starts with space ID to mark a word boundary. Sequences list of lists of integers, and we initialize it, and then we loop through words in, or should I say W in words of text, and we call this function here, so we split it. So we loop through all the words in the text, and it said b to v dot encode UTF-8, not 9, UTF-8, and then in sequences we append it. We should say we append space ID. Asterisk B. Why the asterisk though? Then we return the sequences with the list of lists of ints. So we create a list of integers, initialize it, and we loop through all the words in the text, and for each word we encode it. We set the B. The B variable. And the B here stands for bytes, or it's a bytes variable, or it has a byte value. And we encode the word with UTF-8, and we append it to the list of lists of integers. What's the use of an asterisk in Python?
Sure. So in Python, an asterisk can do a couple of things depending on where you use it. For example, when you put it in a function parameter like *args, it basically means take all the positional arguments and pack them into a tuple. If you use it in front of a list or a tuple in a call, it unpacks that sequence into separate arguments. So it's a handy little tool for flexible argument handling.
What about in front of a variable?
Yeah, absolutely. When you put an asterisk in front of a variable in something like an assignment or a function call, it unpacks whatever's inside. So for example, if you do something like first star restful, the first variable will get 1 and the rest variable will get everything else in a list, like 2, 3, 4. It's basically a way to gather up the remaining items.
So if we have a list of lists of integers and we append to that list with sequences.append parentheses square bracket space id comma asterisk b close square bracket close parentheses, and b is a byte value. What does that mean? What's the point of the asterisk in that scenario?
Yeah, great question. So in that scenario, when you do something like putting an asterisk in front of B inside the list, you're basically unpacking B's contents. So if B is something like a bytes object or any iterable, the asterisk will take all the elements inside B and spread them out as individual elements in that list. So you're basically saying, hey, I want to add a new list where I start with ID, and then I add each element from B as its own separate item. So it's just a neat way to expand whatever's inside B directly into that new list.
I don't know if I'm not understanding it correctly or something, because wouldn't that make like the space marker here appear at every byte character? Like bytes here has to stand for this is the word in binary, and then we have the space ID, which is 256. Wouldn't that like place 256 and like in front of every integer value inside bytes or B? It's a bit confusing to me, like how this would even like look. Like what does this list of integers look like? But I suppose I can figure that out later. Let's just continue with the next function. Init tokens bytes to a list of lists of integers tokens byte ID underlying byte sequence for that token base I for I in range 256. Oops again. And their base append zero x20 base ID maps to an actual ASCII space byte. Return base. I'm just gonna keep going, I think, without thinking too deeply about everything. This is confusing though. I mean, I don't know what this is even supposed to be. A byte? I don't know. I thought space ID was 256, but maybe this is how bytes appear. Anyways, so we set a pair type, which we define as a tuple of 2 integers, and then we create a function called count adjacent pairs with a sequences parameter of lists of integers, and we want to return a counter for a pair. Counter pair counter. So we initialize counts as a counter pair, I think. And then we loop through each sequence in the sequences, and we loop through every I inside the length of the sequence. Every something. I'm not entirely sure. So what we're doing is we loop through all the sequences, and in each sequence we also loop through all the bytes. I think it's a list of lists of integers, so it should be bytes at this point, and we add them to the count. Basically, we add that one plus its neighbor to the count as a pair. And then we return it. And then we have the function called apply merge to sequence. Want a sequence variable, which is a list of integers. And then a integer and a b integer. New ID integer. And we want to return a list of integers as well. So out list int I equals 0, n equals length of sequence, while I is less than n if I plus 1 is less than n, and sequence sequence I equals a, and sequence I plus 1 equals b. So if it's a pair, then append the new ID I plus equals 2, so iterate by 2. Otherwise we append the sequence or that part of the sequence in itself, and we iterate by 1. Then we return out. So here we're merging to each sequence, or to a sequence, should I say. We loop through the whole length of the sequence, and as long as we're not out of bounds and the current part of the sequence equals the first parameter and the next part of the sequence is the other parameter, then we append both and iterate by 2. Otherwise we don't merge anything and only append the current, or should I say we don't change anything. The new ID is something else that gets passed along, probably like the merged version. It says apply merge, so it should be the merged version at that point. But otherwise we don't apply the merged version, we simply pass the already existing value along and iterate by 1. And we return it as a list of integers, or a sequence in this case. And then we have the train function. It's a lot smaller than the last time, but we also have a lot more functions. So I suppose that balances it out. Let's do the define train byte BPE text parameter as a string, vocab size as an integer, and we want to return a dictionary, which will be the model probably. And let's just copy this here. Train byte level BPE on white space delimited words. White space delimited, does it mean like words that are separated on with the white spaces? That should be the meaning, I believe. Return a model dictionary with the tokens. It's token as bytes then, which is a list of integers. And token ID to underlying bytes. Or token ID is underlying bytes, probably. And merges return as a list of integers. A, B, probably tuples. In learned order, space ID as an integer. Okay, so this is the metadata of the model, probably. But let's actually write it. So vocab size. If vocab size is less than 257, raise value error. Vocab size must be greater than or equal to 257. 0 to 255 bytes plus space token. Alright, and then tokens. Tokens bytes. That's not a parameter, it's a variable we set here. So init token bytes merges list of integers, and we initialize that one and start from raw byte sequences with space markers. Sequences equals text to byte sequences text. And greedy BPE loop. I don't know why it's greedy, but we'll see. So while the length of tokens bytes is less than vocab size, pair count equals count adjacent pairs sequences. Is this a what's a counter? Yeah, a counter of tuples. And if not pair counts, if that's empty, then we break. Otherwise, best A, best B, frequency equals pair count dot most common 1 0. If frequency is less than 2, break. Don't create one-off merges. New ID, set to length of the tokens bytes. Tokens by tokens dot bytes dot append tokens bytes best A plus tokens bytes best B. Merges append best A and best B. Sequences equals apply merge to sequence best A best B new ID. That rhymes. Neat. Apply merge to sequence. wrote it wrong up here. Or wait. No, I actually missed a whole function. I'm blind. I'm literally blind. Okay, so it should be sequences, yes, and then we have the function here called apply merge to sequences, and we want the parameter sequences, which is a list of integers, and then a as an int, b as an int, new ID as an int. I want to return a list of integers. How did I miss this one? Return apply merge as a sequence, so we call this function here, or this function here, SAB new ID for S in sequences. So we do that for all the sequences. Or wait, we return a list of integers. Oh, there we go. All right. So the sequences, we apply the merge to it by supplying the sequences the best and the first best one and the second best one for the first and the second token of the best pair, and the new ID for that pair. I think, and the new ID is simply the tokens bytes, and tokens bytes is what? Oh, so underlying byte sequence for that token. A bit confusing, but we'll get to that later. Return tokens bytes. Tokens bytes merges space ID as space ID. So this is the model we're returning here. And we create a function called save model. Model is a dictionary, path string. Want to return nothing. Oops. Wasn't my intention to run it. Exit. I accidentally pressed Shift and Enter together. So that was why it ran some kind of... It ran Python as a standalone, I think. Anyways, with open path. What's open? Can't I actually get to the point where it's at? But it's a system function anyways. And we have the path, W, and encoding UTF-8. As F. JSON dump, model F. Ensure ASCII false. And like that. Load model path. Say string. Want to return a dictionary. Just the loaded model is my guess. We open path are for read, also W is for write and this is for read. Encoding UTF-8 SF return JSON.load. That sounds wrong somehow. And then replay merges sequences list of int merges likewise a list of integers and new start ID is integers and we want it to return a list of integers. Okay, so reapply merges in learned order. We don't need new start ID explicitly because we don't mint new IDs here. Merges map pairs to fixed IDs. A and B to ID assigned during training, which is indexed in tokens _ bytes. Okay. Oops. What about that one? And a duplicate, of course. So, during training, new IDs were assigned incrementally. We can infer them. ID of merge k equals new start ID plus k, where k is 0 based index into merges. Okay. 4K A B in enumerate merges new ID new start ID plus A sequences equals apply merge two sequences A B new ID return sequences. Then we have we define encode text string model, it's a dictionary and a asterisk and do norm bool to lower bool and list want to return a list of integers. Text equals normalize text do norm equals do norm and to lower equals to lower and sequences equals text to byte sequences text merges equals model merges new start ID equals 257 first ID minted after base 0 to 255 plus space ID 256 and sequences equals replay merges sequences merges new start ID flatten into one stream of IDs. IDs equals list of integers of TID for S in sequences for TID in S. Return IDs. And then we have decode IDs. IDs iterable of integers. Model of a dictionary. And so a string, we want to return a string. And we have tokens bytes as a list of integers and a model of tokens bytes. Out equals byte array for TID in IDS. Out dot extend so extend tokens bytes TID. Drop the very first leading space if present. We prefix each word with space. If out and out 0 equals So x20 del out 0 return bytes out dot decode UTF-8 errors replace. Wait, what's wrong here? So it's out like that. And then we have the function called token bytes to string token bytes, which is a list of integers. Want to return a string. Let's copy this one here. Printable token string for export. Decode as Latin 1 1-to-1 byte mapping and replace literal space with G. Submerge s.text is unambiguous. I mean, this as a space would be kind of ambiguous, but let's just go with it for now. Even though I don't really understand why G would be less attention grabbing than a simple white space. Decode Latin 1 return s dot replace with whatever this is. Well, and then we have the export GPT-2 files. Model dictionary, train text. It's a string and out prefix as a string. I want to return nothing. Let me just drink some water. And copy this one here. Exports out prefix dot merges text. Oh, so these are different files. So out prefix merges text pairs in original order. Stringified tokens. Out prefix vocab JSON frequency ordered tokens as an ID mapping. Note frequency ordering is only for export. But we might want to do that later, perhaps, for the model as in itself. Not only for the export. Maybe. I don't know. We'll figure it out later. So token byte is a list of integers. And we want to set that as the model of tokens bytes. Or the value of the tokens bytes key in the model dictionary. And then the merges is the same, a list of integers. For the model key value of merges. There we go. And here we have merges txt with open. Formatted strings. Out prefix. Dot merges dot text. Oh, and this is like that. And oh wait, no, like that, and then W for write, and encoding UTF-8 as F for A, B in merges. So for each of the value in merges, when looping through them, A, capital A equals token bytes to string tokens bytes A. Capital B equals token bytes to string token bytes B. F write. F. Oh, should say formatted. A. B. And a new line. Frequency ordered. Wait, no. Frequency ordered vocab on the replayed train data. New start ID equals 257. Sequences equals text to byte sequences of the train text. Sequences equals replay merges sequences. Merges new start ID. Flat IDs equals a list for TID for S in sequences for TID in S. That is this is complete gibberish to me at the moment. I think my brain is too fried to figure it out. Frequency equals counter of flat IDs. Cover all tokens even if unseen. All IDs equals list. Range len tokens bytes. All IDs dot sort. Key lambda. I don't know what lambda means, but it's a symbol, I think. Like a Greek symbol. If I'm not entirely mistaken. Frequency gets like alpha and beta, and sigma. Get I 0 I. Build printable strings. Strings equals. This means a list, right? Yeah, a list. So token bytes to string TB or TB in tokens bytes. Vocab equals toc strings I. Rank for rank I in enumerate all IDs. With open f string out prefix dot vocab dot json, and we want to write encoding as UTF-8 as f, oops, and json dot dump vocab f ensure ASCII false indent 2. All right, and then we have the CLI with command line interface. None. CLI or CLI stands for command line interface, right?
Yep, exactly. CLI stands for Command Line Interface. It's basically just a way of interacting with the program through text commands in a terminal or a console, rather than using a graphical interface. So yeah, you got it.
I just got paranoid for no reason that I had forgotten the definition of CLI or CLI. Had to double check. Arg parse, argument parser, description, byte level BPE, teaching version. I don't know what it means by teaching version, but sub add sub parsers. Oh, just equals. I'm stupid. Then we have a p train sub dot add parser train help train a byte level BPE model and p train dot add argument input help training text file p train dot add argument dash o or /out default byte bpe dot model dot json. And ptrain add argument /vocab size type integer required true ptrain add argument /lower action store true, set that as a boolean. ptrain dot add argument /normalize, and we set that as a boolean as well, store true. Encode sub dot add parser encode with the help of encode the text using a trained model. Encode add argument model src equals p encode add mutually exclusive group required true. src add argument. So we can only have one of these. src add argument file. Encode add argument lower action store true. Encode dot add argument normalize action store true. And then we have the decoding. So p decode sub add sub dot add parser decode with the help of decode a comma separated ID list. Decode dot add argument model. Decode dot add argument IDs required true help comma separated integers. And then we have exp. So I don't know what exp stands for. My first guess would be experience, but that can't be right. Export perhaps. Oh, it says export here. I'm stupid. Add parser export help export GPT to style files exp dot add argument model exp dot add argument input with the help of same training text for frequency counts. Just double checking that line. And then we have exp dot add argument out prefix default to GPT to export. Args equals p.parse args. If args.cmd equals train. Let me just double check this for a quick second. I can see an error, so let's just pretend everything is fine and hope for the best. So with open args.input R for read encoding UTF-8 SF raw equals f.read text equals normalize raw do norm equals args.normalize to lower equals args.lower. So we call the normalization function. But we don't actually normalize anything in this scenario, I don't think. Considering, yeah, we have this commented out here. The case fold will still work though. Where were we here? So model equals train byte BPE to the main train function, and we supply the text and the vocab size as the args.vocab size, or underscore vocab size, I should say. Yeah. And then we do save model args out, print a formatted string called save, or should I say containing saved model to args.out. Elif args.cmd equals encode. So we want to encode, then we do model equals load model args dot model. If args dot text is not none, raw equals args dot text, not rags, args dot text. Else with open args file we read encoding UTF-8 as f. Raw equal f dot read. IDs equals encode text. Raw model do norm equals args dot normalize to lower equals args dot lower print dot join string I for I in IDs elif args.cmd equals the code. Model equals load model args.model. And IDs equals integer s for s in args.ids.split. If s.strip. Text equals decode IDs model. Print text. Held if args.cmd export model equals load model args.model with open args.inputs are encoding UTF-8 as f. Raw equals f.read export GPT2 files model raw args out prefix print formatted string wrote args.out prefix dot vocab dot JSON and args.out prefix dot merges dot txt, and that's that. Now we have the function calling the main function here. So if name equals main, then we call the CLI. It feels weird to not call it the main function and call it the CLI or the CLI. It was a lot of new stuff, like with open as F. I think it makes sense, but I'm not entirely sure. It's a bit confusing. But there's even though there's like a lot of changes from the previous, like byte pair encoder, this is still pretty legible for me. Legible, not legible. It's pretty legible for me. But I think I'll need a thorough, like, comb through all of this to make sure I understand it perfectly. Or at least better than now. Because then we have the testing here and the stuff like that, but that will have to wait for another day, I think. I can feel like my head hurting from thinking too much about this. I tried like keeping like a mental mental decoding of what I was writing when I was writing it, like multitasking, trying to understand what I was writing and simply not copying it word by word. And I think the added effort actually made it easier to spot errors and stuff like that before they cropped up. But it's made me a lot slower in the head right now. I'm a lot more tired. So yeah, this will be it for today, I think. And I'll probably come back to this tomorrow. And then I'll either on Thursday or Friday, I'm not entirely sure yet, but later in the week I'll play some more Wingcraft. That's the plan at least. So yeah, thank you so much for watching. Smash those buttons and cheers!